Right, so now this is another method that we can use to solve the IVP. So also the Taylor method lah. The Taylor method, just now we are using Euler method, or also known as the Taylor method order 1. And also in this syllabus, in our syllabus, we also can solve the IVP by using the Taylor method order 2 and also order 3. Okay, for example, for the order 2, from the Taylor method, we focus until the second derivative. So we are using this formula for the order method order 2, and for the order 3, so we have until third derivative. Okay, so all this formula will be given, so you don't have to memorize lah, just apply the formula. Alright, for example, so consider the IVP. So we have dy dx plus y cos x equal to 1/2 sin 2x, and also we have the initial condition. So approximate y 0.5 by using the Taylor series method of order 2 with h equal to 0.25. Right, okay. Right, so just now we have dy dx. X with the condition given to 1, and then the range is not given, but they give us h equal to 0.25. Okay, right, the range is not given, but the question asks for y 0.5. Right, okay. Okay, so first we have to do this timeline with our x naught. Even the question does not give us the range, but we can know what is the x naught and also xn from the initial condition given. Okay, this is from the initial condition. So obviously when y 0 equal to 1, so this one is equal to y x naught equal to 1. So from this initial condition, so we know x naught is equal to 0, because IVP, the initial condition will be given, so obviously we can know what is our x naught from the condition given. So our x naught equal to 0, x1 equal to h equal to 0.25, and then our x2 equal to 0.5. So xn equal to 0.5, because the question just asks for y 0.5, so we just need to stop until x2. Right, so this one from the initial conditions just now, we have y naught equal to 1. So what we need to do is, if we want to find y 0.5 here, if we want to find what is the answer for the y2, we need to find what is the answer for the y1. Okay, right. So from the Taylor method order 2, from the formula yi plus 1 prime. Okay, so this is the formula. This is the formula from the Taylor method order 2, but from the question they just give you dy dx. Dy dx is equal to y prime, but from the formula of Taylor method, we need to find what is the y double prime. So what you need to do is, you have to differentiate one more time to find the value for to find the y double prime. Okay, so from the question, so we have the dy dx kan, so dy dx also equal to y prime equal to negative y cos x plus 1/2 sine 2x. So differentiate once to find the y double prime. So by using this one is by using the product rule. UV prime plus V U prime. Okay, and then plus 1 over 2. Differentiate sign, we get cos 2x. Don't forget to differentiate inside, so we get 2. Okay, so for the first step, I'm using the product rule, and the second one, I'm using the chain rule. So the formula, so the answer will be y sine x negative cos x y prime plus 2 cos 2x. Right. Okay, so our task now, we need to find y1 by using the formula. So I should be equal to 0, because when I equal to 0, so we can get our y1. Okay, so equal to, you can do one by one, or you can just use your calculator lah to include the answer, to get the answer. So I know 1 plus h is 0.25, and then y prime is equal to negative y0 cos. Please make sure your calculator in radian mode, because our angle in numbers, so please make sure your calculator in radian mode. Cos x0 is equal to 0 plus 0.5 sine 2x0. Okay, and then plus h over 2, h over squared over 2 factorial, and then y0 prime is equal to y0 is equal to 1 sine 0 minus cos x0 I think we need to repeat one more time, right? Because to find y0 we have y prime, so my suggestion, maybe you can find the answer one by one first. For example, y prime, so we have negative y0 cos x0 so here we have negative 1, so y0 sine x0 minus cos x0, y0 just now is negative 1, and then plus cos 2x0 0, so we get 2. So now the answer will be y0 1 plus 0.25, y0 prime is negative 1 plus h squared over 2 factorial times with 2. So this will be your answer, 0.8125. So this is y1, and then the question asks to find for the y 0.5. So I equal to 1, y2 equal to y1 plus double prime. Right. So first my y1 first, so negative y1 8125 cos x1 plus 1 over 2 sine 2 times x1. So from the calculator, negative 0.5475, and then y double prime is y1. y1 is 0.8125 sine x1 minus cos x1, and then y prime just now is negative 0.5475, and then plus cos 2x1. .6091. Okay, so now y2 is equal to y1. y1 is 0.8125 plus h negative 0.475 times 1.6091. So this will be your answer. To 0.7259. So this is your answer. Okay, so back to the question. The question asked to find the approximate y 0.5 kan. So y 0.5 also known as y2. So this will be your answer. But no choice. If you want to find y2, you still need to find y1. Okay, so this is the Taylor method order 2.